Okay, welcome. These symbols we use to make flowcharts, and flowcharts are part of an algorithm. An algorithm helps you understand the way a program functions and how it runs, And the algorithms can be represented in so many ways. I'm going to focus on two ways, using flowcharts and using pseudocode. Now, using pseudocode, I'll also be showing you some sample codes for some programs. Okay, so that's how we're gonna run here. Now what you see here, this is your start button, and the red one, it terminates the program. The decision maker is right there. It's a diamond shape, no and yes, or true or false. It's a boolean. And you have this parallelogram, which is input and output. A lot of the programs, when you're gonna show how they function, a lot of programs will start with the input or output because they are waiting for you to enter data or activate something, like press a button. So you're gonna have to use the input and output for almost every program, really. Direction arrows, you have red, blue, and green. Blue is bi-direction, red is one direction, and green shows you a direction going upwards. Okay, and you have the process, which is a rectangle. Processes are those functions that happen in the background, the ones you don't see happening. Okay, like adding things, multiplying, subtracting. You only see the results. Okay, so those are processes. You don't see it happening, but it happens in the background when the program is running. A database stores data or information. They can be represented with since this form of a tank with some lines across. So that is one as well. There's a basic calculator, okay, and you could be given a something like this. Now I won't be making code for this one, but I will show you code for the others. The basic calculator. This device has a display screen that allows the user to enter a number, then the sign to be used for calculation, then the second number, and then when the equals button is pressed, it works out the answer and displays it to the screen. Now this is just a basic calculator. There's so many other types of calculators, scientific and so forth. Okay, so draw a flowchart to illustrate how a basic calculator functions. Okay. So we're gonna take out a few important bits of information, and that's called abstraction. Okay. The first one is display screen. Okay. Now remember, a display screen is our parallelogram. Okay. Input and output. Now you have enter a second number, again input and output. Enter a number. These are the words that are important to us, okay? And it works out the answer, it displays the answer, and it also allows you to enter a math sign like a plus or a minus or x or times sign, asterisk, or a forward slash for divide, okay? Then you press equals or enter. Right. Here's an example of a flowchart for a basic calculator. Okay, you're gonna start, input a number, okay, then go down, input a sign, input a number, second number, then it moves on to checking if you entered them right. Okay, correct input format. Is the input format correct? Number, sign, and number. If yes, then work out the answer. Now we'll look at that later on. And if not, please enter a number, a sign, a number, and then press equals or press enter. And then, so that's when it shows you an error message. Then it moves on to reset your calculator. Okay, it erases everything on the screen, and then it asks you to input a number. However, if you entered the numbers in the right format and the sign, it's going to calculate it and then output your answer and terminate. Now, speaking of calculating things, remember you've entered numbers and it's checked if it's the right format. Yeah, here, if it's the right format. So now it's gonna check, is the sign a forward slash? Because it's gonna show you, divide means forward slash, or forward slash means divide. Is the sign X? So it wants you to enter X, not the asterisk. Okay, enter the X, letter X. And then if the sign is forward slash, it's gonna get the answer is equal to the first number divided by the second number. Then it shows you the answer and it ends. But if the sign is not a forward slash, it's gonna check, okay, is the sign X? If yes, answer is equal to the first number times the second number. And if the sign is not an X, letter X, then it's gonna use whatever signs you typed in, the plus or minus sign, and then it's gonna say answer is equal to the first number, then the sign, whether plus or minus, and then the second number, and then display the answer. That's what the function of calculate does. And like I said, these functions or methods, so they are background events that happen. So you won't see this happening. It happens in the background. But that's the logic behind it. Here's another example, an Oyster card reader. The bus Oyster card reader, and this is brief, very brief. I didn't go much into detail, and if you get some time, probably have a look into it and see how it checks the card details, how it scans your card, and so forth. Now remember, it beeps 9 times and it flashes a green light each time. If the passenger is under 16 years of age, now I don't know, maybe it's now 18 or whatever, but if they're under a certain age, it's gonna beep 9 times. However, if it's an adult, it's gonna beep maybe 1 or 2 times and then check the card details and so forth, take off the money. So you can, when you get, try and see if you can expand on this flowchart. Okay. However, this is the, quick way of understanding it. It's gonna scan your card. Then after scanning your card, it's gonna check your card details. Now scanning a card, I use the parallelogram input and output because it's inputting your card details. Yeah, it's receiving card details from your card. So I would call that, now some people would say maybe that's a function because it's scanning the card, it's reading off data of your card, but at the same time it's also receiving data from your card. Now that's like 2 in 1, a function and input and output, so you can organize them that way, whichever way you like, but I only use the input and output function, input and output sign, as if it's receiving data from your card. However, there's a function just before that because it's got to read from your card. Then it's going to check the card details. Now I would say probably here's where it checks whether you are underage or above the certain age, and also whether your card is valid, also whether your card is actually, it has money on it, and so forth. It's going to do that using this database, TFL Oyster database, Transport for London. Probably in your country it's probably something else. Yeah, it's going to check your card details on the database using maybe a wireless connection. Then if there's something on it, that's where we use a double direction or bi-direction arrow, this arrow here, because information is coming from the database and going back and feeding back to the function. So this function you see here, or sub program, it has a lot of things going on. You might want to imagine everything that's probably going on, write it down on a paper and see if you can expand on this flowchart. However, anyway, moving on, is the card valid? If no, show an error message, beep, make a sound to alert the the card owner, and then after 5 seconds clear the screen and reset, and then scan the card again, or get the machine ready to scan the card. If the card is valid, beep 9 times and then move on to the next customer. Okay, so it's not going to terminate because this is a continuous process. Okay, it's the beeping, it's the sound of the Oyster card reader or the machine that alerts the driver whether this passenger should take a seat or leave the bus or use another card. So we'll be looking at the next short program of ours, which is dividing by 7, in the next part of this video. Thank you.